Good morning to everyone. Today I am going to present myself on the topic of Brinell and Vickers hardness tests. First, let's see about hardness. And what is hardness? In general, hardness usually implies a resistance to deformation. And if we see particularly for metals, it is a property which measures their resistance to plastic deformation. And hardness indicates various material properties such as wear resistance, strength, and durability. It is mainly used in quality control, material selection, and heat treatment verifications. Hardness tests are mostly non-destructive, and there are three general types of hardness tests which are performed, and they are scratch hardness test, indentation hardness test, and rebound hardness test. Scratch hardness test measures the ability of a material to scratch one another. Scratch hardness test is measured according to the Mohs scale. In this Mohs scale, the softest mineral is talc, which has a hardness of 1, and the hardest mineral is of diamond, which has a hardness of 10. Rebound hardness. Rebound hardness is also known as the dynamic hardness. In dynamic hardness, the indenter is usually dropped onto the metal surface and the hardness is expressed as the energy of impact. The most common example of dynamic hardness test is the Shor's scleroscope, which measures the hardness in terms of the height of rebound of the indenter. If you talk about indentation hardness test is classified into three types, and that is Brinell, Vickers, and Rockwell. In this presentation, I am going to share both Brinell and Vickers hardness tests. In both Brinell and Vickers hardness test, we use the same principle, which is indentation. And in both hardness tests, the hardness is measured by the size of the impression. And let's move on to the topic of Brinell hardness test. Brinell hardness test. Brinell hardness test was proposed by J. A. Brinell in the year 1900, and it is the first standardized hardness test to be performed. The principle of Brinell hardness test is indentation. In Brinell hardness test consists of indenting a metal surface with a 10 mm diameter steel ball at a load of 500 to 3000 kg, varying in the range of 500 to 1000, 1000 to 1500, 1500 to 2000, 2000 to 2500, and 2500 to 3000. And the load is applied for a standard time of 30 seconds, and the diameter of the indentation is measured with the microscope after the removal of the load. And the surface on which the indentation is made should be relatively smooth and free from dirt, so as to get a uniform hardness on the surface of the material. Brinell hardness test number is expressed as a ratio of load divided by the surface area of the indentation. It is given by the formula BHN equal to P divided by pi capital D by 2 into capital D minus square root of capital D square minus small d square, which is also implies P divided by pi capital D T, where P implies the applied load and the capital D implies the diameter of the indenter, that is of the steel ball or the tungsten carbide ball, which has a unit of mm, that is millimeter, and small d, which is the diameter of the indentation, which is also in the unit mm, and t is the depth of the impression, which is also measured in mm. And the unit of the Brinell hardness number is kilogram per millimeter square. And the Brinell hardness number can be expressed in an alternative way of Bhn equal to P divided by pi by 2 capital T square into 1 minus cos pi, where theta is the included angle. The advantages of Brinell hardness test are: it is good for rough surfaces and it is very suitable for large components, and average hardness over the large area. The limitations of the Brinell hardness numbers are it gives a large indentation and it is not suitable for thin materials, and optical measurements are required. And now let's move on to Vickers hardness test. Vickers hardness test. Vickers hardness test also has the same principle of Brinell hardness test, which is indentation. Vickers hardness test uses a square base diamond pyramid as the indenter. The included angle between the opposite faces of the pyramid is 136 degree. The angle 136 degree is chosen because it approximates the most desirable ratio of indentation diameter to ball diameter in the Brinell hardness test. Because of the shape of the indenter, this is frequently called the diamond pyramid hardness test. The diamond pyramid hardness number or Vickers hardness number is defined as the ratio of load by the surface area of the indentation. It is calculated from the microscopic measurements of the length of the diagonals of the impression. The diamond pyramid hardness number is expressed as in the formula dph equal to 2p sine theta by 2 divided by L square, which is also equal to 1.854 p divided by L square, where p is the applied load, L is the average length of the diagonals, which is in mm, and p is in kg, and theta is the angle between the opposite faces of the diamond, which is equal to 136 degree. Vickers hardness test is most widely accepted because it provides a continuous scale of hardness for a given load, from very soft metals with a dph of 5 to extreme hardness materials with a dph of 1500. The loads used in this test varies from 1 to 120 kg depending on the hardness of the metal to be tested. The Vickers hardness test is described in the ASTM standard of E92-72. And if a perfect indentation is made with the perfect diamond pyramid indenter, and the indentation would be square. The advantages of Vickers hardness test are: it is suitable for all type of metals, and it is accurate for the thin materials also, and it provides small indentation, and it provides a continuous hardness scale. The limitations of Vickers hardness test are: it required slow and careful surface preparations of the specimen, and allows greater chances for personal error in the determination of diagonal length. Difference between Brinell and Vickers hardness test. In Brinell hardness test, we use an indenter of steel ball or tungsten carbide ball. In Vickers, we use diamond pyramid. In Vickers, we use diamond pyramid as an indenter. In Brinell, the load range from 500 to 3000 kg, and in Vickers the load range from 1 to 120 kg. The indentation size of the Brinell harness test are large, and as for the Vickers, it is small. Brinell harness test is suitable for thick materials, and the Vickers harness test is suitable for both thin and hard materials. Accuracy of Brinell harness test is moderate, and as that of Vickers is very high. In Brinell, the surface preparation is seen less strict, as that of Vickers. It is followed very strict, and it must be smooth and polished. And if we see about the conclusion, Brinell harness test is the best test for large and coarse materials, and that of Vickers harness test is best for thin materials, and it also has a good precision in determining the hardness of the materials. And the both hardness test measures the resistance to indentation. Each test to be performed depends on the material thickness, required accuracy, and surface condition and application purpose. Um, and finally, the both tests are very essential in materials engineering and quality control.